My name is Himali Kakshpati, and I'm gonna walk you through this Python notebook, which is part of the chapter from this book named Build a Large Language Model from Scratch by Sebastian Rakshka. Okay, so let's get started. Okay, this is chapter 2, and actually the code starts from chapter 2. There's no code in chapter 1, so I will explain the code in chapter 2. Okay, this is all freely available on GitHub. Okay, so here we are using this package called importlib.metadata, and we're importing version, and then just importing, just printing the version. And let's see, this chapter covers data preparation and sampling to get input data ready for the large language model LLM. Okay, so basically we're building an LLM from scratch. Okay, so the first stage is, of course, data preparation and sampling. Okay, and this chapter implements this part. So this is what we're. So this is the whole pipeline, and we are going to talk about only this section, this part today in this video. Okay, so this chapter implements the data sampling pipeline. Okay, so now we'll go through each of these stages as we go on in subsequent videos. So, okay, first thing is data preparation and sampling, and then after that we'll do attention mechanism, and step 3 is gonna build LLM architecture, and we're gonna pre-train that LLM architecture that we built, and then we create a training loop, and then we do model evaluation, and then finally we'll load a pre-trained weights and run it and see the difference. And after that, once it's pre-trained, we can fine-tune it. Okay, so in fine-tuning, by fine-tuning you can make it a classifier or personal assistant or any other type of model. Okay, so understanding word embeddings. So what is embedding? Embedding is basically turning this data, which is not necessarily in numbers, to a vector of numbers. Okay, so that is called embedding. And the word embedding is words. We take words and we can convert each word to some fixed dimensional vector. Okay, so for example here, for example, if you're doing a video embedding, then video embedding, so you have a model, it's also a neural network, and then you send this video sample, and that sample is fed as input to the neural network, and then this neural network gives you the corresponding vector. Okay, for example here, this is a three-dimensional vector with the numbers 1.23 minus 0.31, 0.89, and this sample, video sample, is converted to corresponding a vector, corresponding vector, which is called the embedding. That is the video embedding vector. Likewise, you can turn, for example, audio sample, and we send it through some neural network, and this neural network will turn this into a vector, corresponding embedding vector. Right. Likewise, in LLM, because in LLM we mostly work with text words, right? So this textual data is fed to this text embedding model, and this text embedding model turns this vector into a vector representation. Okay, so normally it's a high dimensional vectors. Here, for illustration purposes, there are only 3 numbers shown, but actually they're in the hundreds. Okay, so LLM work with embeddings in high dimensional spaces, sometimes thousands of dimensions, as I mentioned. So since we can't visualize such high-dimensional spaces, we humans think in 1, 2, or 3 dimensions. Okay. So for example, here this will illustrate what is embedding. So here, for example, if you look at this figure, um, this is the plot of the embeddings of the words that we converted over here. Okay, so then this, for example, um, if it's two-dimensional, for example, uh, some words like eagle, dog, goose, and long, longer, longest, and so on. So these are converted to text embedding vector, right? Embedded. Okay, so and they are plotted in 2 dimension. Okay, so then so they are actually uh, they are actually they live in this 2 dimensional space, right? And as you can see there, see in this figure, similar meaning words always they um, clump together, means they stay together. For example, eagle, dog, goose, they are all birds, right? Different kinds of birds. So they are actually the numbers are, you know, uh, created in such a way that they're actually together. Okay, likewise long, longer, longest. Okay, since these are very similar words, right, or the derivative of the same word long, longer, longest are derivatives of long, derived from long, right? Okay, so they are together. Likewise, see Germany, Berlin, London, England. So these are places. So they are actually together in the vector space. Okay, so tokenizing text. So tokenizing is, what is tokenization? Tokenization is basically giving every word or token. Um, first we need to um, uh, split these. We have um, a body of text, and then we're going to have to split those body of text into tokens, and tokens may be words or punctuations and such. Okay, so in this section we tokenize text, which means breaking text into smaller units, so individual words and punctuation characters. Okay, so um, okay, so over here it's shown in this figure, as shown in this figure. So this is an example. So this is a sentence called "This is an example," which is the input text, and this input text is broken into tokens. For example, tokenized text. So this is one token, is another token, and is another token, example is another token, and full stop, this period, is another token. Okay, so this is what we're going to do next. Okay, so this is a sentence, right? This sentence is tokenized, means broken down into words and punctuation. Okay, and after that, once that is done, each word is given a unique integer value, like here. So this is given 40,134 is given the number, an identity, or ID rather, ID 2052, and is given the ID 133. Example is 389, and the period is 12, and so on. Okay, and after we have token IDs, then we need to embed, just like shown up there. Okay, so like we did embedding over here, just like that, we're going to embed these token IDs to a fixed size vector. So here, for illustration purposes, there are only 3-dimensional vectors shown. So they all are the same size vector. Okay. So for example, the word this, which is just the token ID 40,134, is converted to or embedded as a 3-dimensional this vector. This one is converted to this um, vector, and so on. So these all are in vector form. Okay, and we send those vectors into a GPT-like decoder only transformer, and there are post-processing steps, and we have the output text.